what if geospatial software was built from the ground up for the cloud? What would be different? How do we design things differently? What would result from that?
Welcome to another episode of the Mapscaping Podcast. My name is Daniel and this is a podcast for the geospatial community. My guest today is Chris Holmes, and today on the podcast we're talking about Cloud Native Geospatial, what it is, where we are now in the process, and what it might mean for the future of our industry. Just before we get there though, a little bit of housekeeping from my side. Firstly, I want to say a big thank you to Jason Wang. Jason, I hope I pronounced your name right, and thank you very much for deciding to support this podcast on Patreon. I really appreciate it. So Patreon is one way I'm trying to make this podcast sustainable. And there'll be a link to that in the show notes if that's something that you're interested in supporting and being a part of. Another thing I'm doing is that I've opened up for sponsorships. So sponsorships on the Mapscaping website and sponsorships on this podcast. So my hope is not to overwhelm people with sponsorships. I think there's enough podcasts out there that do that already. I don't want to be one of them. But if you're a company that is listening to this and you think that you might be a great fit, have something of value to offer this audience, then I'd really like to hear from you. Another thing I'm doing to help make this podcast more sustainable is I'm working with companies and organizations to help them create content. So I'm not talking about the usual sales pitch content, the kind of stuff that starts at, we at insert name of large organization here believe in these 7 things. I'm not talking about that. I'm talking about the kind of stuff that people will care about. So if that's you, if you need help making the kind of content that people will care about, then reach out to me. Maybe I can help. Hey Chris, welcome to the podcast. It's absolutely great to have you here. I've had people calling me up saying, you need to talk to this guy. So I'm really excited about the conversation. We're going to be talking about Cloud Native Geospatial today. I know you have done a lot of work in this field, but I also know you've got a really sort of deep background in geospatial in general. I wonder, before we start, for the sake of context, if you could let the listeners know who you are and how you got involved in geospatial before we head off and talk about the main topic.
Awesome. Yeah, of course. Psyched to be here. Thanks for having me on. So my main role is at Planet Labs, doing a bunch of different stuff, but I get some time from open from them. I work on product and I worked on sort of our overall strategy. In terms of background, yeah, I think it's been over 20 years in geospatial now, which is a little scary to say, but yeah, my first project was GeoServer. So I just graduated from college in 2001, and the internet boom was falling apart, and found this little nonprofit that was doing open source and urban planning, thought it sounded cool. And so GeoServer was at kind of version 0.1. And that was my first thing, was building that community and taking it to 1.0 and 2.0, and then building an organization that was known as OpenGeo and then became known as Boundless. So yeah, that's sort of how I got into geospatial. So I was very deep in the vector, did stuff with OGC. So we were the first web feature service reference implementation. 1.0 was probably the first big coding project I worked on. Worked with Cardo, who those guys are awesome, in between, and then joined Planet roughly 8 years ago, which was my introduction to raster and imagery. We had sort of touched it, but not, I'd never been super deep on it. And then, yeah, it's been cool doing cloud optimized geotiff and stack kind of in that context and going deeper. And then, yeah, more recently, I've started to get back into vector and actually realized how much I had missed in vector. I sort of thought I was just learning raster, but remembered all of vector. But then working on cloud native vector and those types of ideas that I'm sure we'll get deeper into, I had sort of forgot a lot of it. So yeah, I talked to Paul Ramsey and Eric Engel at Google, and they sort of upped my education again. So yeah, I'm sort of getting back to a balance between the two. But yeah, that's the overall rough path through, yeah, open source and open standards, and then Planet.
I'm kind of a little bit curious though. Would you describe yourself as a developer today?
No, definitely not. Yeah, so I coded for 2 years on GeoServer. Was my first job out of college, and yeah, I was definitely doing development in Java. And then we had these community members join through the open source process, and I was doing the community leading and development. But yeah, Andrea Im, who's amazing, Ian Schneider, Gabriel Roldan, they also joined the project, and I realized that they're all way better coders than I am. Like they were doing real architecture, and they were all super experienced, and they were much faster. And so that's when I sort of started doing everything else to make GeoServer successful. So I shifted to documentation and business development to bring money in, to get people aware. And what I sort of realized later was really product management. I wasn't a formal product management role, and community building, attracting people and figuring out what to build. So making sure we had a nice user interface that people could do administration of it as opposed to text files, and figuring out what features to build. So I kind of shifted out of development, honestly, after 2 years. I mean, I do recommend everybody to get some professional development. It's an amazing skill to have in the back pocket. And then sort of paused for a while. I came back, and actually, when GeoJSON was an emerging spec and JSON was emerging, that was the last bit of real coding I think I did, where I did the output format for GeoServer in maybe 2008 or something for a week or two, a week of coding, which was awesome. And then, yeah, I like occasionally dabble. I tried some open layers in JavaScript to do the cloud optimized GeoTIFF, just a little demo map. But it's one of those things where it always feels just not the most efficient use of time, because there are developers who can code things literally 5 to 10 times faster I can, whereas spending my time on writing, on explaining, on product management, on organizing, on community building, on strategy, lots of that takes other people a lot longer than it takes me. So it always feels like a good division of labor, but I always miss it. Like coding, I think is awesome. I think it's the coolest skill. It's the one place where time can just fly by. So I kind of dream about finding the time for it. But yeah, I would say I'm very, very far from actual development. But yeah, try to stay involved technically and aware of stuff, and yeah, be as technical as I can without coding every day.
The promise of this episode is that we're going to talk about cloud native geospatial. But just before we get there, I'm wondering if you ever have like a bad conscience for moving away from the technical side of it. So I started off, I'm sure, like yourself and a lot of other people, very, very technical, focused on the technical stuff. I did my best to learn every language I could get my hands on and play with every piece of new software that came out, and I absolutely loved it. But later on in my career, I started to sort of lose interest in it and move off and explore other things. And for some reason, I walk around with this almost bad conscience sometimes that I'm not more technical than what I guess I imagine I should be. Do you have any of that?
Occasionally, I've had some of that. I think it's hardest when you're closer to it, like that moving away from it. I had to cut myself off programming because I would use that as the tool to just code my way out of something. And I see that a lot. And then I think the other tough thing is coding, you see such immediate feedback, such immediate results. You leave at the end of the day and you fixed a bug, you added a new feature. And I think with a lot of the other stuff, it's harder to see that results. But I think that after a few years I saw those it's longer feedback loops, but in some ways they're bigger and they're kind of more satisfying. I think you can have a bigger impact than just coding every single day, unless you're, one of those master coders, of which I was never going to be. So I feel that it's like more about everyone finding that niche, and yeah, and I think once you find that, it's easier. I mean, I miss it. Yeah, I think right now I miss it, but I don't feel guilty about doing it because there's a set of other skills that, yeah, I know I've developed that work. So
Well, I guess you're just a little bit further on your journey than I am. I still walk around with a bad conscience sometimes.
yeah, you'll get there. Yeah, let it go. You're doing cool stuff. Like find that niche, and
Thanks. That sounds like some good advice. So, cloud native geospatial. If you had to describe that to me, what is it? What is cloud native geospatial?
so the way I think originally articulated was, what if geospatial software was built from the ground up for the cloud? What would be different? How do we design things differently? What would result from that? GIS has been in a very desktop paradigm. You're on your desktop, that's your power machine. You download all your data, you do your cool analysis, and you send it off to somebody else. But that's not how the cloud is. The cloud, does the processing right there, but the cloud also has kind of infinite compute and infinite storage. So on your desktop, you can store the whole world. You would focus on a particular part of it, and you could do a lot of processing, but you couldn't do a global set of processing. So cloud native geospatial I see is what results from starting from this point where you have infinite storage, infinite compute. It can be costly, and what can you do with that, and what are the workflows? How are the workflows different? And I think the other key part of it is the browser, and you want to be able to see it and visualize it and work with it, but your interface is kind of not all your data there. You actually have all the data of the world. And then within that, it's just, yeah, what are those standards? What are the workflows? What makes it possible for data to actually be worked on directly, tapped into all these amazing cloud tools that makes it work, but then also is interoperable and is not just kind of one platform that is super cool, but is really a true ecosystem.
Okay, so a couple of things stood out for me there. Infinite storage, infinite compute. You mentioned the browser there. Does it really matter how we interact with the data? I mean, what client we use when we think about cloud native geospatial? Could desktop app, a browser, or whatever? Does it matter?
Yeah, totally fair point. And yeah, like fully agree that it doesn't matter. And you should be able to have a desktop tool be that interaction to it. It shouldn't matter that browser. I think the browser kind of shows what's possible as that super lightweight client. But yes, there's good reasons to have a desktop client still. Yeah, you might be more comfortable with it. It might have some data locally. Yeah, so I really like QGIS in particular, I think, has really embraced this cloud native thing where, yeah, you can have cloud optimized geotiffs or cloud optimized point clouds on the server, but have Q just run its operations locally by pulling just what it needs. But I think, yeah, the key thing is it's more of a client server architecture with streaming from the cloud where the data lives on the cloud and you pull the pieces you need to do the operations you want. But that processing could happen directly on that cloud, or it could be some hybrid of some on the cloud and some streamed to your desktop to combine with stuff. So yeah, and mobile as well clearly is a little different than a browser. You could have mobile clients that are working in a cloud native geospatial way as well.
So this leads nicely on to the piece of the conversation where we talk about data formats. You mentioned cloud optimized geotiffs, COGS, and I'm not sure what to point at when I think about vector data, but maybe we could start with raster. So when we think about raster data in a cloud native geospatial environment, we're thinking about COGS. Is that it? Or are we thinking about something else as well?
Yeah, so cloud optimized geotiff, I mean, it was kind of the thing that almost set off this cloud native geospatial movement. It just really hit the right thing at the right time to distribute data where it could be streamed, but it was still just a geotiff, so you could download it as well. You didn't have to live in the cloud. It would work backwards compatible with any sort of other thing. So I think it really emerged with the things that geotiffs are good at, kind of multispectral data. I think once you get beyond multispectral data, past 10, 15 bands, then in traditional GIS, this is where your breakdown was between a geotiff and then a multidimensional gridded format like your NetCDF and your HDF. I have never gone super deep in those, but it was always clear to me there's kind of two sets of raster data, and that exact line between them is a bit blurry. But at some point, if you're into hyperspectral data, if you're into weather forecasting and modeling, you're just going to have so many dimensions that you doesn't make sense to have in a geotiff and thus in a cloud optimized geotiff. So the other big set of cloud optimized formats are those multidimensional ones. And there's one that really stands out, which is ZAR, which, yeah, really came from the climate science community and that modeling community, and is actually a more native cloud format than geotiff in that it has less of like a legacy analog, but I think NetCDF is adopting it, and yeah, it'll do that kind of big multi-dimensional thing and store a ton of data. The other one to mention is TileDB, which is a format that's comparable to ZAR, and some people have seen better performance with it. And yeah, it's another one sort of in the mix in that native cloud optimized raster space.
So oftentimes when we talk about these kinds of data formats, this phrase comes up again and again, range requests. Can you tell me what that is and how this fits in with the cloud native part of the equation?
Definitely. So yeah, it's the kind of key enabling technology of cloud native. It's part of the HTTP protocol. When you type in HTTP colon slash slash, like that requests a page. And it was a slightly later developed one that lets you request a particular part of a file. So the way everyone saw this first was with MP3s or movies. If you had one of those files online, you can move forward and backwards in it and kind of request just the middle of a song. You didn't have to download the entire song to have your browser make use of it. You could actually play it online through the browser by selecting where you want it, and the kind of HTTP mechanics behind it would request just that part. But it's a generic thing, and so what all the cloud optimized formats do is make smart use of that range request. So what they all tend to do is put somewhere very upfront in the file a kind of table of contents that says where everything is. And then it's a very ordered way of having the data in a single file in, say, a GeoTIFF in a LAS for point cloud. And so it's a single file that lives online, but you're not having to download the whole thing to get at the particular place you want to look at. So the range request lets you look at those first bytes. It tells you the whole table of contents, goes back to your client, and your client then you say, sort of, I want to look at this part. I want to zoom in here. And then it will know to grab just the part of that, gigabyte, 100 gigabyte file that you want to see, that you want to work with, that you want to stream to the browser to see tile requests on. So that range request is that key enabling technology that lets you select a particular part of the file. And so, yeah, it's all organized to help enable that range request.
That's the first time I've heard someone compare this or a cloud optimized GeoTIFF to a MP3. And I guess this is part of the technology that really enabled Spotify, right? That idea of being able to stream data, having everything stored in blob storage and then streaming MP3s. It'll be really interesting to see what we do with this in geospatial land. A couple of things to follow up on here. When we talk about streaming and getting things down in our client in terms of cloud optimized GeoTIFF, we are talking about actual data, right?
Yeah, full bit depth, full band, the actual all the data. Yeah, to do whatever you want with it.
And are these read only or read and write requests that we can make?
They tend to be read only. Let me think. Yeah, it's mostly optimized for read only. I think some of them could handle some write requests. That's a good question. I mean, I feel like I've been living in this is another one where I've been living in raster land for so long, and people less do writing of rasters. You make a copy and you make a new one. So yeah, I think they're in general they're much more optimized for your read request, and you might want some other tech to like help modify it and produce it.
Excellent. And thank you very much for that. That was raster. That was a really brief but brilliant overview of what's happening in rasterland. What about when we think about vector? What can we do there? Are we still running some kind of SQL server in the background in order to sort of facilitate these reads and streaming of data, or are we doing something different?
Yeah, so vector, the answer is much less clear. And yeah, I put a blog post up on this that was, yeah, I had this visiting fellowship with OGC and I got to explore a lot more and learn a whole lot more. And yeah, my hope was to discover the cloud optimized vector format that just worked. Like cloud optimized GeoTIFF, it was kind of just there and we could rally around it. Like Howard Butler did very similar playbook to COG with cloud optimized point cloud, with the LAS format, everything was just about ready to go. And with vector, nothing is quite ready to go. So what that answer looks like is a bit less clear, but it does seem like there's something there. I mean, Flat GeoBuff is definitely the leading one right now, and they do allow, yeah, kind of it's the same upfront as the spatial index and the table of contents, and it can be streamed down. And then there's a couple sort of cloud optimized vector tile formats. So like MB tiles is a SQLite database. There's equivalents of that, like PM tiles that are optimized for the range read requests. But I think it's still a much wider open field as to what exactly that format is that streams well in the cloud, that lets you both visualize it and have the full data for processing of it. And I'm less sure if that's even there will be one format that does both of those, or if we're going to kind of have linked formats where one does more analysis, but you're still going to have a bunch of vector tiles that are used to render it. So
All of those formats that you've been talking about, as far as I understand, and please correct me if I'm wrong, these are open formats. How important is open formats, open standards when we think about cloud native geospatial data formats? Is anyone working on closed formats or doing something on the other side of the court?
yeah, it's interesting. I don't know of any closed formats. Like raster, there was definitely a set of it was like Mr. Sid and ECW for a while that were doing more innovation on the raster side. The vector side, I mean, we have shapefile, which is not super open. Like the core of it's open, but the pieces around it are open. We actually, Paul Ramsey in particular, was pushing this idea of a cloud optimized shapefile, which would have this benefit of this great backwards compatibility like a GeoTIFF. But I think that's one where doing a cloud optimized shapefile would probably be to make different sidecar files. And so it'd be an alternative. But I think that's a good sort of point of like why the closed formats don't really work is because you're constraining innovation to just the person who made it or the company that made it. Whereas open, that it enables a lot more innovation of different people to build on top of it. And I think especially when we're exploring new things, you need that. You want an implementation to, that reads it to say, oh, you could change this in the format and kind of evolve it together. So yeah, I see open formats as really essential. And I think we've seen a trend in the broader IT world, in the last 20 years of just more open source, more open standards. It's hard to compete with that because you have to figure out exactly what you keep closed or yeah, that's just you can't replicate the amount of stuff that's been open and the amount of innovation. So I think to really take off it pretty much needs to be open.
That makes a lot of sense to me. Although I would say that I think that Google Earth Engine would be a good example of something. I don't believe the formats they're using their background are open at all, but they've created this entire ecosystem which seems to be functioning incredibly well and very lively as well in terms of the development there. That might be the only sort of really great example I can see of someone creating an entire ecosystem that is essentially closed.
Yeah, that's a good example and is interesting too because they are embracing cloud optimized geotiff more. And indeed, Planet has been one to push them because, yeah, yeah, you're 100% correct. They have an internal format that is pretty similar to a cloud optimized geotiff, has the same performance characteristics, but yeah, is their internal format. Before we actually launched Cloud Optimized Geotiff, they're one of the key people that I talked to because I wanted to be sure that they would be able to read a cog. And kind of getting their thumbs up that it was like, hey, if this data is out there and distributed, we would be able to use Earth Engine on cloud optimized geotiffs. And you're going to have like some slight performance hit because, yeah, it's not the format their system was built around. But I think it's really important to build a real ecosystem. Like Google Earth Engine has like a very robust ecosystem, but it's not everything. And I think that's part of why they've embraced COG is they know that they're not going to get every single data provider to upload their data to Earth Engine. As a platform provider, you would love that, but as a data provider, you're like, I don't want this to be my only distribution channel, and I don't want to have to create a whole bunch of custom data just for this one. And so, like the way Planet is actually now starting to work with Earth Engine is that we produce cloud optimized geotiff, we put them into a bucket in Google Cloud, and then we can register them with Google Earth Engine. The Earth Engine has added this function in the last 2 or 3 years where yeah, you don't have to ingest the data into Earth Engine, but you can keep it as a cog and then stream from it. So, and then like Earth Engine also, yeah, has output formats that go into it. So, like, I think they very much like open formats and understand that to be really successful, you need to embrace the open formats because it's just many people will put their data into your particular format, but once you get into really big organizations that are making huge decisions on that, they don't want to rely on that. They want the open option. They want to know that they're not stuck on your platform. If it turned off, if it went out of business, if some decision was made. So I think like open formats provide that backstop that enables everyone to play with each other. And yeah, you always want to find your niche that might be closed. Like you need your business model, you need something to like drive that engine. So I think it's fine to make some things closed, but I think people are finding that the formats as the thing to be closed just makes less sense. Pixie is actually a really interesting example where they had a really sexy format that was super fast. They do full motion video and yeah, big raster data. And this was 10 or 15 years ago, and they sort of realized that they couldn't just sell a format. And so what they did was they put an open interface on top of it for a OGC web map service and web coverage service. And so they could then have that interoperability. Their format was what made their server faster than anything else, but they just knew that nobody was going to go for sticking all their data in this format. But they would go for, hey, here's a web map service interface that they could swap out to something else, but they had an advantage in the format. So I think if you are going to do a closed format, your play is probably to do something, yeah, more like that, put it behind some standard interfaces and make that your advantage versus try to say, buy this format, buy the right to put your data in this format because it's just not worked for too many people for too long that people are hesitant to put all their data in a format that is proprietary that could go away.
I think too, when I think about open formats, I think you're more likely to benefit from the network effect if you are open in some way, if the thing that you're creating is shareable and consumable by other people. And I think in terms of a business decision, I mean, you just can't ignore that now on the internet.
Yeah, definitely.
So I think the other part of this, or the part we haven't talked about yet, we've talked about this idea of infinite compute, infinite storage. You've walked us through a few of the different data types. But I think the bit we haven't really talked about is the discoverability of this. For me, anyway, I think this is where Stack comes into it. Do you see this as having a really pivotal role in terms of cloud native geospatial?
Yeah, definitely. I mean, and yeah, Stack's probably the project that I've put more into than anything in the last 5 years, and a lot of it is that we need to get this data discovered, and it came from this just feeling like our current discovery paradigms for geospatial data just aren't working. You have these portals that you go to, that you search on. You have to know which portals to go to. It's all distributed, but it doesn't kind of work in the same way. So Stack was really an attempt to have a radical simplification of that paradigm, and indeed to kind of flip it on its head, looking at the web. Like looking how metadata and search is done there. It involves people publishing web pages, having their data in a machine readable format, and then companies like Google come along to make sense of that when there's enough valuable information there. And I think with geospatial, we've never really gotten to enough valuable information there, to incentivize someone to build something. So our big goal with Stack was to make it so the data is there. It actually has the link to the cloud optimized geotiff, which you can stream right away. It's not just, oh, contact this person once I've found this data and maybe they'll mail me a copy. It says, hey, we want to access this, we want it streaming. And yeah, it's really kind of a complement to these cloud native formats, because once you find it, you can start streaming it. Stack itself does not need to be a cloud optimized format. It kind of says, let's make this simple language and unite around the same terms and values to discover stuff, be it satellite imagery or other types of data. So we want it to be that bridge as well, where you might want to download that format, but kind of key is that that data is online. It's not hidden behind somewhere else or go contact somebody else. And then that data can be crawled. So to publish the data, you just can put a Stack JSON record on the cloud next to your data, and then somebody else can make that index. Somebody else can crawl it. Somebody else can stand up that service. So the barrier to sharing your data ideally is much lower.
This sounds like search engine optimization for geospatial data.
Yeah, I mean, I think eventually, like, I think first it's search engine existence for geospatial data. like, and I think that's a lot of it is like, can we get enough data in there where search engines start to look at it?
And so just to be clear, when you say enough data, you're talking about describing the data, right? Like, because a link to data in itself, search engines aren't so interested in that. They're interested in at the moment anyway, a written description. This is what is if you follow this link, this is what you're going to find.
Yeah, exactly. Yeah, it's that sort of piece past it where, it has that information that a human would want to read and understand. Do I want to use this data? Do I want to click download or stream? Yeah, so it's much more that sort of metadata about the data. But then the data also has to be there, so that's why it's the push to cloud optimized formats in general. Like, there needs to be a critical mass of data that is successfully described to then, I think, enable that ecosystem where they might be specialized geospatial search engines. We might get the big search engines to also understand it, but where somebody really starts to think about, what's the page rank? Like for Google, the page rank is what search optimization is working to help, in that the page rank is what ranks things. So like, how could we get to usage ranking of geospatial stuff? You need that rich network of links that kind of links back from derived data sets to the source data set to know, hey, this is the data set everybody's using. Yeah, and Stack kind of like hopes all of that comes, but says, hey, let's focus on a more focused problem of just let's get the data and the metadata available for people to do cool stuff with.
I want to be really respectful of your time. And I hope we've got a few minutes here to talk a little bit about the future. Because when I listened to your talk, I was like, yes, great, I am in. But like all things, not everyone is going to benefit from this straight away. If we had all of this sorted out, who would be the big winners when we think about cloud native geospatial tomorrow? Who's going to be benefit from this first, do you think?
I mean, I think those are two different questions. First, and the big winner. I mean, I think who benefits first? Yeah, certainly the clouds, certainly data providers. I think those are kind of the two, and anyone working on the cloud. having that tool set available, and I think it's having that data available. Yeah, I've recently been interested in just seeing people newer to geospatial come and just kind of assume you can access all of Sentinel, all of Landsat, like that is possible today, and you can build applications on that stuff. So yeah, it's interesting. I think in some ways it's like the younger people who benefit who don't have all the preconceptions of how things used to be, that are kind of just see, wow, there's tons of public data sets and I can just build applications on it. I mean, to me, in the long term, I mean, my hope with all of this is that this is the thing that helps geospatial get out of its niche. Like I've always felt that geospatial is, you learn about it and many people just become converts to like, this stuff is so powerful, I want to work in this stuff, but it remains just us. We try to explain it, we try to get the benefit of it to wider audiences, but people kind of have to come in and learn. And so my hope with this stuff is we're aligned much with the bigger kind of movements of the cloud, and we're in early enough that spatial is more baked into things, and that everything becomes spatial. That kind of our community expands hugely, the number of users who use spatial as part of their everyday and benefit from, yeah, Earth observations and derived data sets and all that the spatial people are doing, all the way into their workflows that enables that. So yeah, that's kind of my hope of who eventually benefits, is that we get to, yeah, that mainstream user who doesn't want to look at an image but wants the information about the Earth to make decisions.
Yeah, it sounds like what you're saying is that we need to think bigger than just like our own silo and then the data itself. And I think that'll be possible for other people to come in and think bigger than perhaps what we have done in the past, if the data is just more available, more accessible, more discoverable.
Yeah, and it's worth mentioning. I mean, the back on the vector stuff, the one format I didn't mention that we just released is called GeoParquet, which is just a kind of geospatial version of this Parquet format that's used in kind of big data, Spark, data scientists, business analyst tools, and then these cloud data warehouses like Snowflake and BigQuery. And I think this is actually one of the potentially really transformative things. Snowflake and BigQuery are taking over the broader IT industry. You can join any data that you have or join it to other data sources. And both of them actually have really great geospatial support. BigQuery was the kind of first, and Snowflake just added it. Amazon Redshift just came out with geospatial support. And these are databases that, are used by people who don't know anything about spatial, but they have really good spatial support. So I think it's so huge that we're in there early, that spatial is a part of it, as opposed to like, some add-on later or convincing somebody to convert their data to something else. And then this GeoParquet format, like Parquet is a format read by all those clouds, and they can stream from it, they can do zero copy, work with it, they can scale up hugely. And adding that kind of interoperable layer on top of it will let publishers just put data out and get into these kind of mainstream things. So that's where I really see where we tip over into the mainstream, is if we're able to produce data that gets published in these formats that then is just easily streamable and instantly joinable with all of the rest of the data out there, where you don't kind of have to like get into a spatial database to make use of spatial. It's just in your query engine, in your, yeah, distributed database.
Sounds like a bright future. I look forward to being involved in it. And we are still talking about the future. What advice would you give to geospatial professionals who are working in the industry today in terms of upskilling or perhaps getting used to some specific kinds of tools? Like, what can they do today if they want to prepare themselves for this cloud native environment?
In general, try to work on the cloud more, like work with these data sets that are there, shift to that kind of stream mindset. I mean, I do think Earth Engine is an incredible tool. Like Earth Engine has shown the cloud native future for 10 plus years. And I think it's very funny because they're very focused on academia and impact use cases. So we're at this weird time where those users are ahead of many traditional users because they focus there and they've had less the interfaces to work with commercial companies. They're getting past that and are building that ecosystem. But that tool, I mean, it's just incredible. Like you can do global scale compute on global data sets. So I think getting comfortable use of that, I don't think that particular tool is like the entire future. I want this interoperable layer that's one of your options, but I think that's one of the clearest things to upskill on and get used to processing data at a global scale and asking those bigger global questions. So that's the sort of today. I think the other one I do think is these cloud data warehouses. Yeah, your Snowflake, BigQuery, and just the power they offer. And yeah, they have spatial data support today. Like, try to work in those, try to do your spatial problems in those. I think they're going to bring that global scale compute to vector data, to tabular data. Earth Engine, I think, has a little bit of vector support, but is really concerned about raster, and that's where it really excels. I think these are going to be, yeah, your kind of global scale geospatial compute engines. So getting up to speed, trying out data in there, converting data into them, and yeah, seeing what other parts of the organization that might be in that you could join with, and what interesting questions can you work with. So yeah, those would be my other kind of two picks of, yeah, SQL and SQL at scale to get towards that future.
Chris, it's been awesome talking with you. I really appreciate your time. I know that you've got to run away soon, so I won't hold you any longer. But before I let you go, where can the listeners go if they want to reach out to you? So I'll find your blog post and I'll include links to them. But if they want to reach out to you personally or follow along with what the work that you're doing, where can folks go to do that?
Most reliable is probably Twitter. I think I'm Open Cholmes at Twitter, CHOLMES. Most people call me Cholmes. And yeah, that's where kind of my default place to go is. And yeah, I mean, can also email me, Cholmes, CHOLMES, at planet.com is probably the easiest one. And yeah, happy to talk to anybody. And yeah, and then I publish on Medium, but every Medium post I put on Twitter. So I recommend just the Twitter. I mean, you can follow me on Medium, but you will see the post on Twitter as well.
Thanks very much. I'll put links to those in the show notes. Thanks again. Really appreciate your time. Awesome talking with you.
Awesome. Thanks so much for having me. It's been fun.
So I really hope you enjoyed that episode with Chris Holmes. I will put links in the show notes of this episode to all the places where you can catch up with Chris and connect with him and follow along with his work. In the show notes of this episode, there's going to be a bunch of links today, so check them out. Just want to highlight this idea of STAC, so the Spatial Temporal Asset Catalog. So this is one thing, making data more discoverable for us, the people in the community. But what Chris was kind of alluding to there was making it discoverable for the broader community as well, through some search engines like Google, for example. Imagine what that would mean. Imagine if you went to google.com and instead of just being able to search for images, maps, videos, and shopping, imagine if there was a button there or a tab there that said data. That would be amazing. If we did make our data more discoverable, perhaps search engines like Google might start to be able to match the user's search intent with the data or the services that we're providing, with data sets. So in a world of Cloud Native Geospatial, where people are using data sets and they are available on the cloud, and perhaps they're doing their research in something like a Jupyter notebook, which means it's reproducible research for the most part. If we're linking back to something on the data on the cloud, that anyone can get a hold of this notebook and start playing with it and step through your exact process to produce what you produced, and then start tweaking it. So in a world where people's research was linking back to common data sets, helping Google understand you can do this with that data set. So in search engine optimization land, we could start thinking of this as this page rank algorithm. What is the best page on the internet to answer this user's query? And then think about the search intent. So let's say I'm a user. I want to do a competitor analysis. There's probably a spatial component to that. Imagine if Google served up a data set. You'll need this data. And if nothing else, it might help people understand that, you can do that with this data. So in that scenario, Google would do some marketing for us. These search engines would do marketing for us. They would help people understand what is possible with the data that we work with, that we're producing, that we're making available. And we seem to have a problem with getting the message out, helping people understand what is actually possible. And I wonder if part of the key might be this sort of cloud native future that we're moving towards, where data sets are available, they're searchable, they're discoverable, and people could discover them by themselves without us having to do that hard sort of educational piece. Going to a search engine and saying, I need this, and then the search engine replying, you can do that with this kind of data. You need this kind of data. Now, I'm not suggesting those people will be capable of doing the processing, of doing the analysis themselves, but just that connection between oh, if I want to do things like this, I need that kind of data. I can do it with Earth observation data. I can do it with geospatial data. The spatial component is important. I think that would be a huge step forward. Towards the end of the episode, Chris mentioned that if you want to prepare yourself for this cloud native geospatial future, you might want to think about investing time and playing around with some of the tools that we have available today. So with that in mind, if you are interested in learning more about Google Earth Engine and about Google's BigQuery, there'll be links to podcast episodes about those two topics in the show notes of this episode. Or just scroll back through the feed and look for BigQuery, Google Earth Engine, and you'll find them there as well. But you don't have to start using one of these massive platforms in order to prepare yourself for the future. If you haven't played around with Cloud Optimized GeoTiffs yet, go to your favorite desktop application and export an image as a cog. Put it somewhere on a server and try and read it again. See what happens, see how it works, see what's possible, see how quickly it performs. Start playing around with these things. Thanks again to all the people that are supporting this podcast on Patreon. It makes an absolutely massive difference, and to be honest, I couldn't do it without you, so I really appreciate your help. And that's it for me. That's it for another episode of the Mapscaping podcast. I'll be back again next week. I hope you join me then. In the meantime, feel free to reach out to me on social media. You can find me on Twitter, LinkedIn, or go to mapscaping.com and join the email list. Okay, talk again soon. Bye.